We're back on part 2. We're finding out how to find roots of complex numbers. I put an n there. It represents a square root or cube root or any root that you prefer. All right, so let's see what I prefer. All right, I will teach that by giving you the method, and then I will give an example, and voila, done. So let's look at, well, first thing you need to know about roots is there's more than one. Do you know how when we took square roots of numbers we got a plus or a minus? Actually, we weren't telling you the whole story when we did cube roots and above. So here it's going to come spilling out. So make a note. There are 2 square roots. That's no surprise. You knew that. When you took the square roots of numbers, you knew there was a plus and a minus. But what we didn't tell you is there are 3 cube roots. We couldn't tell you because you could not bear it at the time.
I'm not sure if I can bear it now.
There are 4 fourth roots.
And 5 fifth roots?
Oh, you read ahead. I told you to wait. 5 fifth roots. Some of us have read ahead and spoiled my thunder here. 6 sixth roots, etc. So if I ask you to find the 6 roots, you have to give me 6 answers. Let me train you how to do that. So you are in root training. You will be asked to draw the roots, and it sounds like a big hard process, but it'll really simplify your life. So suppose that you were finding fifth roots, and you found the first 5th root, and it was like right there. Then you can get the rest of the picture because the 5 fifth roots will be in one circle equidistant from one another. So if there's 5 of them, so you have to just kind of go around 1, 2, 3, 4, 5. Do they look like they're equidistant?
Sure.
All right. So that's all I'm looking for the picture. But the first one has to be in the right position, and then you kind of spin around. So if there was 3, I was asking you for cube roots, and the first one was there, then you would go and you'd be done. So I am asking for the picture, but that's how quick that you can give me the picture. And that will help you mathematically, actually. It has some reason. All right, so how do you actually get the first one? I think maybe, should I teach it with an example?
Yeah,
It's kind of hard to,
I think
all right, let's find by example. It's not a homework one, though. The 6, I want you to find 6 sixth roots of a number, and I'm going to give you the worst case. Normally it's in complex form already. I'm going to give you one that's not in complex form. So this will be the worst case. I think there's 2 like this in your assignment. So let's say I'm going to give you this number, -1. I want you to find 6 sixth roots of -1. So you're actually doing the 6th roots of -1. All right, so you know, first of all, you have to put it in trig form. There's no way to do that. This is a complex number. It's -1 plus 0i. When there's no I part, we know that the I part is held by a 0. What does -1 look like in complex form? Well, if I sketch it, remember these are the reals and these are the imaginaries. So try to sketch -1 plus 0i on this imaginary plane, the complex plane. What quadrant did it fall into?
In between the 2nd and 3rd?
All right, very good. So we went over here because there was no up and down. That's the I part. It only went to the left like this. So the point was right there. So I draw a line from the origin to that point, and I've got to have an angle for that point, and the distance is 1. It looks like it's -1, but remember, this is r in complex form, which is a radius. It's always positive. So it's just the distance from 0 when you're in the trig form. This number is always positive. So
Is it 180?
it is. Another person reading the book ahead of time. All right, so this is cosine 180 plus I sine 180. Now the problems you get that are already in trig form, they'll just present you something like this. But I've showed you a case where you have to start in standard form and switch it to trig form. All right, there are 6 answers. Does it show, Bailey, if I write over here?
Yes.
All right, so first of all, you know there's 6 answers, so number them. You won't forget any if you start with numbering them. So the first thing they do in this method is you take the number outside and you actually take the 6th root of it. So your calculator can do that. In this case, we know what number times itself 6 times is 1. But if it had been a 2, you would have had to put the calculator to work and got a decimal. So the number outside is the same for all of these. When it's 1, I don't have to write it, but I will write it for this example. So that's going to be the same for all of the answers. The only thing that changes is the mess inside of here. So I'm going to write a skeleton of each. When I say a skeleton, I know they're all going to be cosine something, I sine something. So I go ahead and write all my skeletons. This is the bare bones answer. So once I get the angles, I am done. And I found the 6 6th roots of -1.
You just take 360 and divide it by 6.
What you do to get the first one, that's right. You take, no, 180.
180.
And 180, take the number that's in here and divide it by 6. That's
30?
the root. So in this case, it's 30. But to get the other ones, it's quite different. So the first one is probably like you expect. You take the root of the number outside and divide the angle by the root. To get the other ones, so basically, let me go back to the picture. You're ready to draw the picture because 30 is right there and it's 130. So now we can draw the rest of them. So give yourself a circle. And to make 6 that are equidistant, 1, 2, 3, 4, 5, 6. There's my 6. There's a picture of my 6 roots of 1. 1, 2, 3, 4, 5, 6. So, in order, if I know that they start here at 30, how do I get to the next one if they're equidistant and there's 6 of them? Well, once around the circle is 360. If I divide that by 6, the special number that I add to this to get this is 60. And it's the same number I'll add to get this, and this, and this, and this. So
You just add 60
Yeah.
to 30 every time. That's what I thought. I was going to say that, but...
180. What I'm going to need some help. 60. 240. Is that right?
Sure.
Plus 60 is 300. And I messed up somewhere because I went over one circle. What did I do wrong? What's 360? Oh, I know. Yeah, that's the special number. Oh, the first one's wrong. What do you get when you add 30 to 60?
90?
Oh, 90.
Yeah, sorry. Oh, what's an eraser for? All right, 60. I knew I was wrong because I was going to end up around further than 360. So it's all going to fit in one circle. 30 plus 60, 90 plus 60. There's my
150.
And then plus 60, 210. And then plus 60, 270. My picture's a little off, but near 270. Plus 60 is 3 or something. 30? What's 60? Yeah. 330. Alright, so that's the worst case. And if you would allow me, pull out your unit circle and let's go back to standard form. And we'll see more clearly what is the root of the 6 roots of -1. They will be all right here. So, Abby, help me with this one. What's the cosine of 30?
The square root of 3 over 2.
And what's the sine of 30?
1.
Pardon?
1.
Alright, so square root of 3 over 2 plus 1/2 I. You see where she got that? Allie, you help me with 90. What's the cosine of 90?
0.
And what's the sine of 90?
1.
Alright, so that one came out to be 0 plus 1I, or I. But we knew that was an answer because we're familiar that I raised to the 6th is I, so we've seen that before. Or not I, it's -1. Alright, let's see. Bailey, what's the cosine of 150?
Negative square root of 3 over 2.
And the sine of 150?
1/2.
Positive?
Yeah.
Alright, so when I multiply times the 1, which won't change it, I get negative square root of 3 over 2 plus 1/2 I. Hannah, jump in. Cosine of 210.
Negative square root of 3 over 2.
And sine.
Negative 1/2.
Seems like these numbers are just dancing around with opposite signs. Okay. Back to you, Abby. Cosine of 270.
Negative 1/2.
270, that's straight down.
I'm
Oh,
getting
never
close.
mind. 0.
And in sine.
Negative 1.
Alright, so that's negative I. And lastly, Allie, 330.
330 is
Cosine.
It's root 32.
Positive. And then,
Negative 1/2.
alright. So if you go back to, if you switch these back to out of trig form, you can see more clearly what the answers are. If you took if I had time, I could take any of these and multiply it times itself 6 times. And guess what I'd get?
Negative 1.
Right. So I had in my plan to pick one and do that, but you'll have to take my word for it. Alright, our assignment. Does Molly have the back of this blue sheet? Yes, she does. Molly, we're doing now 7 problems since we did 1. And it's on the back of the blue sheet that you already have. And they are. You ready to mark them off? You have your blue sheet out. Okay, they are number 71. Am I on the right sheet? Yeah. 71, 72, 78, and 79. I believe we did 71, right? All right, so we already did 71 in class. Those are raising complex numbers to a root. So the next 4 are finding roots. 90, 91, 94, and 97. All right. See if you can.
We did number 71.
Yeah, I think we did that one in our comp books when I taught this section.
Oh, did
All
we
right.
do 78?
We did 78.
Oh, okay. So let's cross out 78 then. I'm sorry. So we do 71. Cross out 78, Molly. That's the one I did on the board. So we have 71, 72, 79, 90, 91, 94, 97. All right. Eke at least the raising a power to a power, because those go quickly. And are you allowed to leave them in trig form? No, you have to multiply them out, don't you, in that
You
section?
can let us leave them in trig form.
How about you multiply out the first one, and you can leave the others. So multiply out number 71 and put it in standard form. That's where we did this stuff. We looked at our trig circle, our unit circle, and we will just do the one on 71. On the, I'd like you to do them all though on the square roots. Sorry. All right, Molly, I think we're over and out. I hope that you're okay and are getting well or getting a lot done, whichever the case may be. Bye.